Hello, welcome to Good ESK channel. I'm your host Owen Osarinhwe, your senior advocate. In this channel, I always try to bring to our focus any latest development in situations that are particularly related to elderly people, their welfare and their comfort, and the social care concerning them. So one of the areas that really touches me when I see a already compromised individual elderly who, for whatever reason, several issues of life have bogged them down, and a terrible blow like cancer will come in. And over the years, it has been an issue that even with the new researches and new approaches to medicine, we're still hoping and believing for breakthrough regarding treatments and prevention. So a lot of good news in that area. And each time any new development comes, it's always exciting, and it's our believe and hope that one of these days we'll be able to very soon hit a breakthrough regarding cancer treatment, prevention, and cure, hopefully. And there are new developments regarding some of the things that can be preventable. How does, for example, what's the relationship, what's the connection between the food we eat, and the containers we use for the food, the packaging and all that? How does it relate to this disease? One of the recent research in that area is talking about microplastic. How does microplastic in the food we eat possibly cause cancer? Microplastic are like tiny plastic particles less than 5 mm in size, have been found in food, water, air, and even human organs. While research is still evolving, growing evidence suggests that microplastic could pose a cancer risk, especially with long-term exposure. Now here is how microplastic might contribute to cancer. Microplastic are found in seafood, package, water, salt, tea bag, processed and packaged food, and plastic container can cause chronic inflammation, damage DNA, and trigger inflammation, all of which are involved in the development of cancer. These chemicals can interfere with hormones, damage DNA, and trigger inflammation, all of which are processes involved in the development of cancer. Physical inflammation and cellular damage can occur with microplastic are ingested and accumulate also in gut or tissue, leading to increased mutation risk, impairing the body's natural cancer defense. The Trojan horse effect can also occur when microplastic absorb and carry other toxic pollutants, crossing cells, membranes, disrupting DNA replication, and accelerating mutation and tumor development. Now, these are areas where a plastic or microplastic can possibly cause cancer. In this video that we watch, the catchword is, we can now reverse the stage 4 cancer. And this is feeding your cancer cells, especially when made in bold, dramatic ways. Can sometimes be like a misleading information, but there's it's often overwhelming and maybe exaggerated, one may seem, but it's better to listen to the facts. And as one is always hopeful These phrases are common in some of the online clickbaits you see. They often sell supplements, especially diet or alternative cure, with no solid clinical evidence. But when you're listening to an expert in the field that give words of encouragement like this with facts and evidence, then it is worth hearing. Some stage 4 cancer can be managed or controlled. Immunotherapy, targeted drugs, and advanced treatment have led to long-term remission in a small but growing number of stage 4 cancer patients. Now, these are medical breakthroughs, not miracle cures, and they depend heavily on cancer type, genetics, treatment access, overall health. Reversal is also sometimes possible, but it's rare and not guaranteed, and never a one-size-fits-all. Also, yes, some food may support or inhibit cancer growth, but claiming that this food feed cancer is oversimplification, and it needs to be clarified. And the truth in this area lies on the researches that have been done so far. All cells, including cancer cells, use glucose for energy, but removing sugar entirely doesn't stop cancer. Your body regulates blood sugar regardless of the diet. Overeating sugar contributes to obesity and inflammation, which may increase risk, but sugar doesn't cause or directly feed cancer in isolation. Now, cancer is a complex case. Cancer is driven by genetic mutation, immune dysfunction, inflammation, and environmental and lifestyle factors. And not single food, no one single food or supplement can reverse cancer, but a healthy diet, movement, sleep, stress management, and medical treatment together can improve outcome and possibly extend life. Now, really evidence-based cancer supportive diet tips, it may include nutrient-rich food and many other benefits that follows. In this particular documentary, with an expert with a proven record of research and evidence, is the true healing is never built on fear or false promises. It comes from combining the best of medicine, science, lifestyle, and support, honestly, compassionate, and realistically approach style. Come along as we see this documentary together. It's really an eye-opener, and I'm sure you will learn a lot from it. Thanks again, once again, for watching this clip with us.
Dr. William Lee, if someone has just clicked on this conversation and they're asking themselves, they're wondering what they're going to get out of spending this time with us for the next couple of hours, what would you say directly to them that they will learn, gain, and how will their life improve?
I would say that you're going to hear about food in a brand new way that you didn't realize, that a decision that you can make after this, listening to this or watching this, that you can put into action to your life immediately could actually help you for the rest of your life. It could stave off disease, help you feel stronger, even help you with longevity. So it's no single moves that you can make, but it's the beginning of taking steps that can actually allow you to live the rest of a long, enjoyable life.
And what are the key diseases that people are and should be most concerned about today based on their correlation to the food that we eat?
Yeah, if you look at the biggest health crises in the world today in developed countries, you're really talking about cardiovascular disease being the number one killer, diabetes, and all the consequences, the devastating consequences that come out. Listen, your blood sugar is not being very well regulated. That's the definition over time of diabetes, but the knock-on effect of having high uncontrolled sugars is really underlying metabolic chaos. There's a whole litany of terrible conditions that happens every downstream from that, from eye disease to wounds that don't heal, et cetera, et cetera. Cancer is another one. Dementia is a bigger and bigger problem as our population ages, and a lot of people don't recognize this. But the saying that inflammation is a root cause of chronic disease, scientifically correct. But there are many, many inflammatory diseases that are out there that don't get enough airplay, that really take away the quality of your life as you get older. And so I think all of these things, it's not just about mortality, it's about morbidity. It's not just about living long, it's about living well and feeling good along the way.
And where do you think we are as a society, especially as Westerners, as it relates to our relationship with health and food? Because when I look at some of the stats around life expectancy, there's been a bit of a stagnation in, I think it was 2020-ish time. But then also when you look at a lot of these chronic diseases, whether it's diabetes, whether it's cancer, these things seem to be on the rise. So as a nation, it feels like we've got more information than ever before. But when you look at the objective numbers, for some reason, we're not going in the right direction. What's your 30,000-foot view on it?
30,000 foot, there's more and more people in the world. So once you get huge numbers, the diseases that affect most people are going to magnify. So just as a matter of math, we're going to see more of these chronic diseases. But we're also going to be seeing two things that are happening that actually oppose each other. One thing is that the lifestyle and dietary harms that have occurred over 20, 30, 50 years, from the industrialization of food, from the industrialization of healthcare, from degradation of the environment. Those are all things that take time to manifest. And so to some extent, we are presently seeing the fallout of some of the not so good moves that we made in the 1950s and 60s and 70s and so on and so forth. So decades later, we're beginning to see the consequences, the devastation of things that happened decades ago. That's one side of elevating, increasing the incidence and prevalence of health conditions, bad health conditions. There's another side that is countervailing. And the other side, which is the side that's the team I play on, is it really exciting. Because one thing that's different is that we now have tremendous scientific power to get in there and probe diseases and also indeed probe health, which is something we're not doing often enough. And in so doing, we're actually able to find solutions to the problems that counter some of those harms. So we're beginning to discover now, how do we actually prevent diabetes? How do we prevent cardiovascular disease? Can we reverse heart disease? And even conditions that seemed like no-win situations. And I like to talk about this, is that in my career, I never thought as a physician I would actually see the cure to cancer, the end of cancer. But actually, I have to tell you, I have now seen where the end of cancer is coming from. I've seen how the war is going to finish. Because I've had well over a dozen patients, and there are hundreds of people like this that are starting to form, that can go from stage 4 cancer, that's game over cancer, to stage 0. We can do this. And not for everybody yet, but we're beginning to see where the light at the end of the tunnel is, and it involves your immune system. And some of the remarkable scientific breakthroughs are teaching us that our body heals itself against diseases as serious as cancer in ways that the pharmaceutical industry can't by itself do, but it really relies on the body. So when you talk about food as medicine or medicine as medicine, none of them are as powerful as what the body is hardwired to do by itself.
When I think about something like cancer, it's slightly terrifying because it feels like a game of roulette. It feels like the people that get cancer, it's completely random, and that our outcomes are also a game of roulette. And this is as someone that knows very little about cancer. I hear someone that I thought was very, very healthy get cancer, and then their outcomes, whether they beat it or not, also seem to be largely down to chance sometimes. That's how it seems. What do you think of that view?
Yeah, I'm going to give you a brand new view of thinking about cancer. And that is that we are all forming cancer in our bodies all the time from the time we were kids. You don't have clinical cancer, you haven't gone to the doctor to get a diagnosis, still start forming cancers. And let me tell you why. Cancers are like pimples in our body. All right. And this is shocking to some people to hear, but the human body is made up of about 40 trillion cells. That's more cells in our body than stars in a clear sky. All right. And these cells have to divide to be able to reproduce themselves, copy and paste. Every cell has its own genetic material called DNA. It's our instructions for how our cells are work. So you get to copy and paste your DNA. All right. Now, copying and pasting is a tricky thing to do really well. So if I gave you a sentence to write, Stephen, and I said, copy it 10 times on a Word document, you'll do it perfectly. If I told you to copy it 1,000 times, you're going to make a few mistakes. Good thing that we have spell check to fix it, to catch it and fix it. But if I asked you to copy a single sentence 40 trillion times, you're going to make so many mistakes that your spell check isn't even going to be able to catch all of it. Okay. And that's what's happening in our body every single day as we are replicating ourselves. We're going to make mistakes. And whenever there's a mistake that's being made that isn't caught and fixed, that's a mutation. And so we have mutations that are forming in our body just as an outcome of being alive and doing our thing, and we're not sick from those mutations. But every mutation is the beginning of a microscopic cancer. Take a guess of how many mistakes in DNA of copying and pasting your own body are made every 24 hours. Take a guess. This has been calculated randomly.
There's so many cells in my body, so it's going to be a big number, 1 million.
Okay. Every day, every 24 hours, there are 10,000 mistakes that are made in your body that your body doesn't catch, that propagate in the document of our body as it goes on. 10,000. Each of those is a microscopic cancer. A microscopic cancer is just that. It's microscopic. It's too small to be seen with the naked eye, but it's abnormal. And that thing could turn into a big tumor that could eventually kill you. So why don't we die from cancer all the time? Now, this is actually something that I see as a physician. I have a patient diagnosed with cancer. They always ask me, Dr. Lee, why me? Why did I get breast cancer, colon cancer, pancreatic cancer, brain tumor? A very, very natural question, and I do my best to try to provide an empathic answer to that question. But as a researcher, I have a more interesting question. Given the number of mutations that occur in our body every single day, why don't we get cancer more often? Why don't we all get cancer as kids? Cancer can happen in children, but not as often as we have mutations. And it turns out this was the great unlock for me in terms of health. The reason that we don't become more sick from all kinds of diseases, including cancer, is because our body is hardwired with its own health defense systems. So that we've got these swashbuckling defenses that are firing on all cylinders all day long. From the moment we're born until our very last breath, these systems that are inside our body defend our health, including the microscopic cancers, spots them, takes them out, kind of like a police cruiser patrolling a quiet neighborhood, sees a drug dealer on the corner, pops them in the back of the police vehicle and takes them away, cleaning up the neighborhood. That's how our body naturally cleans up these microscopic cancers. And so when you talk about cancer as a scary disease, you're thinking about the person whose body has failed to detect and eliminate the microscopic cancers, and it's become large enough to actually become a threat. Now, here's a question for you. So we tell women to actually do a self breast exam when they're taking a shower. Look for lumps or bumps, and if you find one, certainly go to your doctor immediately for an exam. The smallest cancer that you could feel with a trained person can feel with their hands in the breast is 1 centimeter in diameter. A 1 centimeter breast cancer already has 1 billion cancer cells that have already multiplied. That microscopic cancer multiplied 1 billion times. That's the smallest one you can feel. Now, immune system's not taking them out, all right? So you need a better immune system if you want a shot at this, and not just chemo or hormonal therapy. And that's where some of these incredible advances are taking place. But there's another one. In order to feed 1 billion cancer cells, you need blood vessels to feed them. So the cancers, as they get bigger, they hijack our own circulation to feed themselves. Okay, it's kind of like terrorists kicking in the cockpit door to take over the controls of the plane. They want to actually get your blood vessels to feed themselves. Now, normally the body knows how to control those blood vessels. It's called angiogenesis, blood vessels, genesis, how the body grows and controls them. That's my area of research. So naturally, our body knows how to prevent blood vessels from feeding cancers, and yet knows how to direct blood vessels to feed healthy tissues. So guess what? A 1 centimeter tumor with 1 billion cancer cells is fed by 100 million blood vessels coursing into the tumor to feed them. And we've studied this in a laboratory. The moment that a single blood vessel touches a tumor, tiny microscopic tumor, it will grow 16,000 times in size in just 2 weeks.
Wow.
All right. So I've told you some scary statistics, but now let me kind of give you where the breakthroughs are coming through, right? So with this kind of knowledge, what can we do with cancers? Not just breast cancers, but in general. Number one, we know that if you boost your immune system with foods, with exercise, diet, lifestyle, you're going to actually make your immune defenses a lot stronger to patrol your body to wipe out those microscopic cancers. That's why healthy diet and lifestyle lowers the risk of cancer. That's why eating the right foods that boost your immunity can substantially lower your risk of cancer as well. We also know that you can eat foods that support, prompt up, fortify your body's natural ability to control blood vessels. Keep those blood vessels where they're supposed to be and get rid of those blood vessels where you don't want them to be, which is kicking in the cockpit to take over your circulation to feed cancers. So if you eat foods that are anti-androgenic foods, like unstable, you've got coffee and tea. Both of those contain natural substances that cut off the blood supply and starve cancers. That's a good thing. So that's why we know what we do with our diet can actually help to lower the risk of cancer as well.
I'm assuming the opposite also applies. I could eat foods, I can drink things that cause my body to malfunction, i.e. makes the blood vessels unregulated, and starts to feed the cancer, right?
Yeah, absolutely. So let's talk a little bit about that. So,
okay.
So I told you the body's hardwired with these defenses, shields up, right? That's what we want to do. Because shields are already normally up, you want to raise them higher. But what about, and this is a brilliant question you're asking, a very probing question. What are the things that take your shields down, right? What are the things that turn off the smoke alarm in your house, that unlock the doors?
Can I take a guess? Is it this?
Okay. Now, I know the answer that you're setting this conversation up for, which is a burger with meat. Is that actually disease causing? And I would tell you that yes and no. A burger is something that many people enjoy eating, and I would say eating meat, eating burgers, even eating ultra processed foods once in a while is not going to harm you if your health defenses are naturally strong. But if you make it a habit, a regular habit of eating this at the expense of eating healthier foods, more plant-based foods, less processed foods, okay, you are actually going to tip your odds where the diseases are more likely to get you. What that means is that overeating fast foods like burgers will actually contribute to taking your health defenses down, shields down.
So what are those things then that bring the shields down? You were saying...
Okay, excess sodium, too much salt, which can be present in a lot of restaurant foods. People eat out a lot, go to restaurants all the time. You ever go to the back of a kitchen or a restaurant to see how they're seasoning their food? Patrons love salty food. It makes food taste really great. Our brains respond very well to salty food. That high sodium levels actually speeds up, accelerates our cellular aging. So we actually age faster, but it also is a huge wear and tear on our health defenses, specifically our circulation. our blood vessels, our angiogenesis system is taken down by excess salt.
Okay, I've got a question here. Obviously, there's a big movement at the moment around hydration and electrolytes. And these electrolytes have magnesium, potassium, they have sodium in them.
Yeah.
So a lot of people are now taking electrolytes to hydrate themselves. Is there a risk here?
So the great news is that the healthy body has got its own titration system for electrolytes. If you drink a electrolyte fortified beverage, your body's going to take everything it needs and it's going to pee out the rest. You're going to eliminate through your urine, right? However, sodium is one of those electrolytes is present. Like you're not drinking electrolyte fluid all day long, but sodium you're eating it in almost every food that you actually have, except perhaps dessert, but maybe even then. And so this is one of the things that we realize is sodium is a high risk for hypertension, high blood pressure, inflammation of the lining of your circulation, and that sets up for a lot of badness downstream when it comes to your health, and it takes down your circulation health defenses that we talked about. High blood sugar can also do the same thing. So if you're eating an excess of added sugar, we all have heard by now, glucose spikes and glucose crashes. I don't actually use those words, by the way. I don't like to actually cast our body's metabolism in terms of spikes and crashes. I think those are fear words that get attention. They do make you pay attention to it, but in fact, really, the healthy body sort of has smooth ups and smooth downs. They're gentle slopes up and down of our blood sugar, and that's completely fine. All right, and it should be like that. However, if you have an uphill climb of your blood glucose and it continues to stay up, that can actually happen if you're eating too much added sugar. Okay, added sugar, ultra processed foods. What happens is that your blood sugars, your intake of the sugar, glucose, rises up, and now your body your metabolism to chase that blood sugar down, and it's got to work harder and make more insulin, and eventually you just wear out that system, and then you have a high blood glucose and an insensitive metabolism, and that's the beginning of sort of the dominoes starting to fall apart in your body. And so sugar, high blood sugar, added sugar is a problem. You get it from fruit, not a problem. Okay, no one's going to be eating a crazy amount of fruit. This is why extremes aren't good. Diversity, switch it out. Keep it interesting for yourself. This is what our human nature wants anyway. It's how we're hardwired. You'll actually be fine. So salt, sugar, those are two offenders. Okay. Alcohol is another one that actually can take down your health defenses over time. People say, well, what about red wine? Isn't red wine healthy? What I would say is that actually the fermented products or the bioactives that come out of red grapes, from the skin of red grapes that's found in red wine, there can be some healthful properties of the resveratrol and other polyphenols that come out of that are in wine, but it's never the alcohol. It's not the alcohol in the beer, the wine, the whiskey. Nope, none of that. The alcohol is a universal toxin. Toxic to your brain, toxic to your liver, toxic to your heart. Can't get away from that. Your body will recover. Shields up. It can take a ding. It's like a drink is sort of like a driving behind a truck, and it flings a little pebble right into your windshield. You might get a little spider in the windshield. Okay, don't worry, it'll repair itself. You'll fix yourself. You'll bounce back. It's not going to break your windshield. But if you keep on drinking, you're actually going to smash your windshield. And that's why alcoholism is so devastating to the health. But, a small amount of alcohol. So alcohol itself is a toxin.
Do you drink?
I rarely drink. And when I drink, it's in moderation.
Mm-hmm. And I was thinking about stress as well. Does that bring down the...
So besides the foods you eat, other things that can compromise your health defenses. And by the way, there are 5 health defenses. We talked about blood vessels. We talked about immunity, but there's 3 other ones that are core to functioning in the healthiest way possible. If you want longevity, you need all 5 of your health defenses and more to be working in your favor. But stress, what does stress do? Lowers your immune system, shields down. All right. Those microscopic cancers, whoa. That's why stressful people are more vulnerable to developing diseases like cancer. All right. Stress also causes your blood pressure to go up and causes neurotransmitters, hormones to be released from your brain and your kidneys, your adrenal glands that actually wear down your circulation. Now your angiogenesis system is also not functioning as well to protect yourself and keep good blood flow going where it needs to go. Now your circulation is actually down. So again, stress also can actually damage the DNA. We talked about naturally copying and pasting and having errors. Add some stress to it. Now it's kind of like you're trying to copy that sentence I was telling you perfectly. Now I'm going to come in and just smash your fingers down every now and then, and let's see if you actually make a mistake. You will. All right. Stress will actually do that. It's devastating to have so much stress continuously. Listen, by the way, I want to be really clear to anybody listening or watching this. A little stress is actually good for you. You know, like just being coddled all day long and living in a
Yeah.
happy bubble. That's not good for our health either. We kind of get lackadaisical, we let our guard down. Little stress. I mean, anybody who's
Wake you up.
hardworking, successful knows that, it's not the no pain, no gain. It's that the grit that goes along with it, which gives a little stress, keeps us sharp, which is a good thing. You want to be on. So a little stress is good, but when that stress is unabated,
Continue.
it literally sinks your health defenses. It is just taking those shields down.
Yeah, I've noticed that with myself. I've spent the last 10 years running businesses, a little bit more than 10 years now, but probably last 13 years running businesses. And the only times when I really get sick, where I'm like out for a week and I really, really feel it, is 1 week after
Rest.
2 weeks of stress. So when I say 2 weeks of stress, what I mean there is when something happens in my life, business, where that it's kind of chronic and it's enduring stress. I can deal with having a stressful day. I can deal with having 2 stressful days in a row. But when I've had like 2 weeks of an enduring issue, like an enduring angst or a problem, almost perfectly predictably, a week later, I'm sick. And I'm extremely rarely sick because I think I sleep really well. I think I eat really clean. And so it's taught me something about if I zoom out on that and see what's going on in my body, well, eventually, like my body's kind of, my immune system is running out of energy almost.
More than in your immune system. So when you're super stressed, it also it interferes with your ability to sleep well.
Yeah.
When you're sleeping well, sleeping is something that I was taught when I was a kid. When you're sleeping, you're resting. And when you're resting, you're not active, right? Well, that's just our physical self. It turns out when we're sleeping, even though our muscles may not be moving like we are during the day, in fact, a lot of other systems, including our health defenses, are being repaired, renewed, regenerated, rebooted while we're sleeping. So in those ideally 8 hours, 7 to 9 hours, eight's the sweet number, our brain is cleansing itself, detoxifying itself, releasing. Do you know about the glymphatic system in the brain?
Not as well as you do.
Okay. Well, there's a sewer system in our brains that's called the glymphatic system, and it's shut tightly during the daytime when we're using our brain, doing our work, whatever we're doing. And during the day, we accumulate a lot of toxins inside our brain during the day. It's just a matter of functioning. All right. And what happens is that those toxins accumulate, which is that, at the end of a really, really tough, hard day, you got, if not a headache, you feel like your brain it's full. The cup runneth over, right? All right. So when you go to sleep, guess what? This sewer system, it's like the sewers of underneath Paris. The grates open up suddenly and it drains those toxins out while you're sleeping, and only when you get good sleep. So when you're stressed and you're not getting good sleep, you start to accumulate these toxins that are never quite cleaned up, and your brain is not that cleaned up. When your brain's not cleaned up, you're feeling foggy. So think about when you're in college, you pull an all-nighter or go to a party or whatever, and you're staying up all night. You're never quite the same. It takes a while for your brain to clean up itself. When your brain is foggy, you tend to not make as good decisions. I'm too tired to work out. I'm too tired. I don't care what I eat. I'm just hungry. I'm going to eat anything. You start to make bad decisions when it comes to diet and lifestyle. You see, so the stress can cascade on your health like that.
Is there a certain stage of sleep where the glymphatic system kicks in?
Yeah, it's during like the deep REM sleep.
Okay.
That dreaming sleep.
Okay, and that usually comes later in the night as well.
Correct.
And in more quantity later in the night, so you need to really be getting a long sleep.
Right. Now, the other thing about deep sleep is while you're sleeping really deeply, your metabolism is also burning down fat. So you think that you're not working out during the night, you're right. You're not actually exercising, but in fact, your metabolism is burning fat because while you're sleeping and your insulin levels don't need to be high because you're not eating, insulin levels go down. Your metabolism shifts gears. I sort of give people the analogy. It's like your body is a race car, sports car, like a Ferrari. During the day, you are in gear to drive, accumulate speed, and you're revving your engines. At night, you shift gears where you're actually burning down fat. You don't need to accumulate more fuel. Now you're burning down the fuel. So when you're sleeping, you're actually burning away fat. But when you don't sleep well, or you don't sleep long enough, you're not burning down that fuel. That fuel accumulates. Day or two of not good no sleep, that's okay. Think about flying overseas, getting some jet lag. You got to catch up. Once you catch up, you feel better. All right. But think about this like day in and day out. Chronically stressed people who are never getting good sleep. Add a little booze, alcohol to the equation. You can kind of see the problems that are going to build up. Your brain's going to be foggy. Your metabolism is going to be out of whack. You're not burning as much fat from the calories that you ate during the day. Now inflammation starts to rise in your body, and that inflammation really takes down your health defenses. And now you're much more vulnerable. So in your own example of where chronic stress leads to poor sleep and then you get sick, no surprise.
If we go back up the thread there, we were talking about the sort of individual perspective on cancer, and I was looking at some stats here, and it says that the number one Google search related to cancer is breast cancer. 1 in 2 people will develop some form of cancer during their lifetime. That's according to the NHS. Cancer is the second highest leading cause of death worldwide, and by 2040, there will be 28 million new cases of cancer each year worldwide. But one of the most shocking things that I saw was that globally, early onset cancer incidence has risen by about 80% by 1990 and 2019. And there was an article which I'd sent to my team a couple of weeks ago. It's called The Worrying Puzzle Behind the Rise of Early Onset Cancer. And it says that there are rising cases of breast, collateral, and other cancers in people in their 20s, 30s, and 40s. And it posits the question, what is going on? Over the last 10 years, rates of colorectal cancer among 25 to 49-year-olds has increased in 24 different countries, including the UK, US, France, Australia, Canada, Norway, and Argentina. I mean, what is going on?
Yeah, that's a big question. So are we seeing the results of more harms in our environment that we're being exposed to that are more toxic and leading to earlier incidence of clinical cancer? They're talking about clinical diagnosed cancer, not the invisible microscopic ones that are forming all the time. It's very worrying. Are we exposing ourselves to something that is more commonly encountered today than before? Number one. Number two, are our defenses being taken down by forces that we didn't appreciate are compromising us? Most likely both. It's most likely, the human makeup hasn't changed. And so it's got to be the fact, a combination that we're being exposed to more harmful things. And though some of those harmful things are actually, provoking more cancers, and we're also being exposed to things that take down our health defenses. So the balance is being tipped against us. And it's true. I can tell you that when I went to medical school, colorectal cancer was something that you rarely saw in people, even in their 50s. It was for much older people. Now to see, there's even teenagers that have actually developed colorectal cancer, which was unfathomable. So I will tell you one thing that's actually arisen in terms of what are some of the clues of these things that could be happening, right? So we are talking about climate change and all the things that are happening in our environment. That's almost too big a conversation to have to answer a question like this. But I think we cannot afford to ignore the fact that the environment, the climate that we live in has changed. But there are other things that we're beginning to unearth that we didn't realize until just within the last few years. And one of them is how many inflammatory microplastics we are ingesting. When I was growing up, my mom, very well-intentioned, would store foods in plastic, leftovers. And we'd buy foods that came in plastic packages, right? We didn't have a second thought about it. A plastic cup, styrofoam cup. Go to a picnic, you're eating off of a plastic plate, right? I mean, these are all common experiences that we all have in the modern developed world. Well, what if I told you that we now realize that the plastic touching food can shed the plastic itself as microparticles into the food, and then we eat the food? And okay, we've known this for maybe more than a decade. Maybe there's little plastic particles that come off. But hey, there's no harm, right? We haven't been able to discover it. I used to say that. Now, just within the last few years, we're beginning to pinpoint that number one, plastics can actually embed themselves in our body. We know where. We also know that these plastics are associated with inflammation. That is a big red flag. The klaxon alarm should start going off. And third is that the volume of plastics that we're consuming is crazy. There was a study that came out recently that showed that in normal autopsies of people that didn't die of a brain problem, that when they were doing the autopsies and looking for plastic, that we could find them. And the amount of plastic that was found in the average human brain is about the amount you'd find in a typical plastic picnic spoon, just distributed throughout the brain. This is like it's a person who's died of something else. Wow. Does that mean that, like you and I are actually, you got a plastic spoon worth of plastic in our brain? There's been some people that calculated, and this has been, the actual math has been challenged, but there was an estimate that, some people might consume as much as a credit card's worth of plastic every single week in their food if they're not careful about it. And let me just tell you where we're finding microplastics. And, I want to get to the point where we're talking about the healthy foods that can actually turn the ship around. How do we turn the battleship of unhealth back to health? So we're back on the course that everybody wants to go to. We want to go to that how do we find our North Star for health? So I do want to get to that, but let me just say something about microplastics. We've now found microplastics in the brain, as I mentioned to you. We found it in the bloodstream. A group in Italy actually looking at men who had narrowing of the carotid artery. That's the blood vessel feeding the brain comes from the heart right to the brain, the carotid artery.
Oh, through the neck.
Through the neck.
Yep.
They found that the narrowing that can occur in some men can accumulate plastic. They can actually find plastic particles. There's photographs of the chunks of plastic, the particles, fragments of plastic in there, and they followed them over a period of time. Those men who had plastic embedded in their blood vessel lining had a 4-fold increase in the chances of having a fatal heart attack or a stroke years later.
400%.
Fourfold, yeah. Okay. Now that's not kidding, right? So now we're beginning to take notice of this, but we're also finding microplastics in breast milk. We're finding microplastics in testicles. We're finding microplastics in human semen. How does it get there? And urologists who are doing surgery on the penis are finding that in the human flesh, when they look into the microscope, we never used to look for this. Now we're looking for it, that there's even microplastics in the flesh of the penis. Okay? So if anybody listening to this isn't taking notice about microplastics now, it's time to start thinking about this. So one of the questions is, and I'm not saying that the rise in rate of cancers that we're seeing is due to microplastics. What I am saying is that we're beginning to wake up to the fact.
So let's close off on microplastics. What are the easy wins in our lives, do you think, when you think about microplastics? Is it just removing anything plastic that I eat from? Or are there some sort of easy, cheap wins? Is it my shampoo? Is it my frying pan? Is it a container?
Yeah, so I always tell people that the easiest way to lower your exposure to microplastics is to throw out your plastic cups, your plastic plates, and your plastic silverware, okay, and get ceramic or glass. That's the best way to actually avoid those. And also when you're buying food, try to avoid food that comes clearly packaged in plastic, all right? Now, I do want to point out one thing, because right here on this table, we are looking at a tray full of beverages, and I can already identify the matcha, and this looks like a cup of coffee, and we've got English breakfast tea. I've done a lot of research on tea, all right? But I'm noticing something, that green tea, which is universally healthy, the polyphenols in green tea lower the risk of inflammation. They actually improve your metabolism, lower your risk of cancer. They're heart healthy. Before you take that sip, though, let me tell you, I see a tea bag in there.
Yeah.
Okay. And there's different ways of brewing your tea. It turns out research from the University of Montreal have now shown that tea bags can shed microplastics.
Oh.
So you can have 1 billion particles of microplastic shed from a single tea bag.
Now that's serious.
All right.
What
So
else
I just
all
changed
those
your mind,
things?
right? So look, this is the power of awareness and understanding. I probably should have stopped you.
Yeah.
But what was you were like? Why didn't you save my life?
You let me drink it first, but I've spat it out.
Well, I just, as you were doing it, I was like, all right. But so look, there's another one there that's got lemon ginger tea. This is like an herbal tea. That's fine. Listen, I would also tell you with flavored teas, just be cautious. Like always check anything that's been machined to be a little bit more than nature. Tea bags are supposed to be paper, right? Well, in order to prevent the paper from ripping, the manufacturers of the tea bags spray it with a small amount of plastic to have it hang together better. And that's the plastic that comes off. But what about the lemon and ginger in this lemon ginger tea that sounds so appealing and calming, right? And something that most people would find nice as an herbal tea. Well, listen, you're relying on a factory to actually put that lemon flavor, ginger flavor. Is it real lemon or is it real ginger? Always look at the ingredient label to know what's in there. Or just buy your own tea and squeeze your own lemon and add your own piece of ginger. These are ways to actually kind of avoid the potential exposures to toxins that come from ultra processed food. So all this conversation about, avoid ultra processed foods and watch out for all those harmful things. It's actually quite easy to dodge them if you just have in your mindset that you're just going to make it yourself, and it's absolutely easy. Now, I will tell you something interesting about English breakfast tea. We did research at the Angiogenesis Foundation, the nonprofit I looked at, to look at different types of teas, different types of green tea, Japanese tea, Chinese jasmine tea, English tea. And we were always assuming, again, this is the power of food as medicine research. We were always assuming that the green tea is going to be the best. I'd always heard that Japanese green tea is going to be like the ultra best. And what we found was that English tea, specifically Earl Grey tea, actually was the most potent when it actually supported your blood vessels, your body's defense system for angiogenesis to keep your circulation healthy. Wow, what a surprise that is. And this spoke to me about the fact that we can't make assumptions. We need to look at facts. We need to look at data. And so I'm a big fan of Earl Grey now. Now, what might make give Earl Grey its superpower? Well, this is where knowing a little bit about what you're eating is actually useful, because Earl Grey is a fermented, it's a black tea. It's got bergamot in it, and bergamot is a kind of a citrus. So maybe it's combining those ingredients that actually provides the superpower. But I do see matcha on this tray. I want to tell you about matcha because matcha is truly a super enriched, polyphenol enriched tea. A lot of people don't realize it. There's no tea bag in it, so don't worry. So a lot of people think about matcha as just another green tea, but it's not another green tea. It is made with green tea leaves, the same kind of green tea leaves, but as you would find in any green tea. However, it's what's the composition of matcha. Matcha is green tea that is, before it's ready for harvest, is grown under a shade that changes its chemical structure, natural chemical structure a little bit. So it's got a lot of potency to it. And what happens with matcha is they take the tea leaf, they take out the stem of the green tea leaf, and they ground up the actual leaf into a powder. Now, what's in that green tea leaf? You've got not just some of the polyphenols that might steep out in the cup, whether you're using a tea bag or loose leaf tea, you're getting all the polyphenols suspended in that. So now you get 100% polyphenol, okay, in matcha. So go ahead, go ahead, do it. That one's good. All right. Okay, for matcha. And because you're getting the tea leaf ground to it, you're also getting your dietary fiber. The dietary fiber is good for your gut health, your microbiome, good for your metabolism, good for lowering inflammation. And the polyphenols found in green tea have also been, matcha tea, have also been found in the lab to kill breast cancer stem cells. What's a breast cancer stem cell? What's a cancer stem cell? Well, look, stem cells are these renewable cells, all right? And cancers contain stem cells that help the cancers come back, right? If you get cancer, you get it treated. The one thing you don't want it to do is to come back. So, and by the way, other foods can also kill cancer stem cells. Purple potatoes that you might have seen in the market, they're kind of purpley looking on the outside. Slice it open, dark purple on the inside. All right. Turns out that those purple potatoes have something called anthocyanins. Purple potatoes have been studied in a lab, okay, at Penn State University and been shown to kill colon cancer stem cells, which contribute to the colon cancer coming back.
So full disclaimer, I made a very, very big investment, a 7-figure investment into a matcha company a couple of years ago. And if you look at the search trend data on the subject of matcha, I don't know if you've seen this, but I'll throw it up on the screen for anyone that's watching on video, but you can see how it's just come out of nowhere. It seems it's exploded. And when you say that matcha cells have an impact on breast cancer cells, what does that mean in reality? Does it, because obviously the conclusion one might jump to is that if you drink matcha, you're lowering your risk of breast cancer. But that's not necessarily what you're saying.
What I am saying is that drinking green tea in its most healthful form, okay, raises your body's health defense systems.
Yeah.
And by having better health defense systems, better immunity, better control of your blood vessels, better control over your DNA and those mutations, and if you can actually kill some of those stem cells, cancer stem cells, that's going to be in your favor as well. That is overall going to actually lower your risk of cancer. And so I think that, and by the way, the other thing that green tea and matcha can actually do is improve your metabolism. It's really pretty much all good. My great uncle, by the way, lived to 104 years old, vital, intact, independent. He told me that he attributed his longevity and his vitality to the fact that he lived at the base of a mountain that grew tea, that every morning he got up and he walked up stone steps, a stone path to a tea garden, and he had freshly picked tea. It's all organically grown and everything. And he drank tea all day long. He probably had 10 cups of green tea a day, and this has been his whole life. He sat with his close friends who are also very vibrant and elderly. Social connection, all right? Watch the sunrise. It's very calming.
Do you drink it?
Absolutely.
I've got just going up the thread again a little bit. You mentioned the word colorectal. Where is the colorectal cancer?
Right. So we have a little model here.
Because I'm asking this because I'm wondering why that type of cancer is increasing. So is there a particular reason why?
Well, okay. So let's do a quick medical school crash course for podcasters. The gut. We talk about gut health. Most people think of the gut as sort of lower down in your belly or maybe even just your stomach. But the gut actually starts in your mouth and it runs down, 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 about 40 feet worth of stuff, organs, your esophagus, your stomach, your small intestines, your large intestines. By the way, these squigglies are your small intestines, all right? This blue is your large intestines. This is it's shaped like a horseshoe. It's big, thick, tube that's kind of framing your small intestines, and then it goes down the poop chute, the rectal, and the anus. That's the end of your gut. All right. So the colon is really the large, framing, thick part of the gut. It's near the very end. All right. So all this squiggly small intestines winds up here. At the beginning of the colon goes up. It's called the ascending colon, and then it makes a sharp angled turn right across your belly, kind of like a belt, right across your belly. This is colon here, and then it goes to the descending colon. Take the elevator down, 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 down. You see the blue down's going down, and then it kind of takes a little jog at the very end and goes down into your rectum and your anus. Okay.
Right. So the blue thing is my colon. So this is where cancer incidence is rising in young people.
So you're talking about the rising incidence of colorectal cancer. That could be a cancer that's typically either on the right side of the colon, either going up the upside, up the elevator, or down the elevator on the right side or the left side.
Okay.
Okay. It turns out that we've known for a long time that unhealthy diets are linked to a higher risk of colorectal cancer, specifically processed meats. So the World Health Organization considers processed meats, salami, bologna, ultra processed, kind of deli meats, delicatessen meats you find in delicatessen. All right. Kind of deli meats, delicatessen meats you find in delicatessen. All right. Those would be considered carcinogens, and they are highly linked to an increased risk of bowel cancers. Now, why would that be? Well, it turns out that, think about it, if you're eating a ton of meat, all right, you're actually exposing the gut to a lot of those processed meat carcinogens that when it sits around in your colon, not once in a while, go to the ball game, have a hot dog, enjoy yourself. But if you eat it day in and day out, you're giving a lot of exposure to your gut.
This term, angiogenesis, you've talked about the link that has to cancer. Angiogenesis, from my novice understanding, is how the blood cells provide blood to different parts of our body, right? And in the case of cancer, there's the angiogenesis system is making a mistake. Is that a simplified version of it?
Yeah. So angiogenesis, which is the field I study, we break it down to what its elemental parts of angio, blood vessel, genesis, how the body grows and maintains them. So angiogenesis is how our body grows and maintains our circulation. A lot of people don't know this, but our circulation is one of our body's health defense systems, and it's so extensive that in a typical adult, there are 60,000 miles worth of blood vessels packed inside our body. These are the highways and byways that deliver blood to every organ and tissue. But that means that they also deliver the air we breathe, the oxygen we're breathing in, and the nutrients that we're eating. So we eat good things, they're going into our bloodstream, and our blood vessels, our angiogenesis system delivering to every cell in the body. Now, you eat something bad, similarly, or you breathe something in bad, similarly, those blood vessels are delivering something negative. Now, inside the blood vessels is a lining. It's called the lining is like a clear, like a plastic wrap inside the blood vessel called the endothelial layer. That's like a layer of ice, like on an ice skating rink, to ensure that everything in the blood vessels are flowing smoothly without getting caught on the walls. So when you have cardiovascular disease, too much salt, hypertension, when you have diabetes, where you're actually wearing down the lining of the blood vessels, endothelial layers being damaged, it's like damaging the lining of your angiogenesis defense system has really deadly consequences, because it's like scraping up the ice on an ice skating rink. If you actually have a lot of ice skaters on a rink, after a while, it's unskateable, right? You can't get on it. And what will happen in your bloodstream is then elements in your blood get caught along the walls and they build up. And that's actually how blood vessels narrow up. So that's one of the areas so angiogenesis actually is intended to deliver oxygen and nutrients to the tissues that need it to maintain your health. But because it's so critical, it's also very, very carefully controlled, so you don't have blood vessels growing where they should not be growing, like in your joints, in your eyes, or of course to cancers. You definitely don't want to be feeding cancers by delivering oxygen or nutrients to them.
I've got this graph which shows different things that cause more or less angiogenesis. If you've seen this graph, but
okay. So you are showing a graph that I generated, my organization generated, and this is actually, you're looking at the experiment that got me into food as medicine. Let me explain to you the experiment. I'll put it over here. So we were studying at one point drugs, and we're trying to discover drugs that could be developed as cancer treatments. So what we're looking for are drugs that could cut off the blood supply to tumors. So we were screening lots of chemicals that biotech companies were developing and inventing, and professors were inventing, and said, hey, can you take a look to see this could be a worthwhile drug that could cut off the blood supply to a tumor as a cancer treatment? All right. And at the time, there were no such treatments. So it was all discovery. Like this was, like the golden age of discovery when it came to angiogenesis. We were testing, oh my gosh, this thing could really stop blood vessels could we develop this into a cancer treatment? Ultimately, yes. The answer was yes, but we were looking for them. And and so we developed a system where we could add a substance into a laboratory test system to see if blood vessels would grow or shrink. And so here on this graph, you can see at the very top a very long bar of blood vessels growing. That's normal, healthy blood vessels growing out as long as they can. And then what we would do is we'd throw drugs into it, and we would see if we could actually shrink them up. And so some of the shorter bars are cancer drugs. You can see them in this color in blue. Not surprisingly, some of the cancer drugs were making the blood vessels smaller. Hey, this could be a good candidate drug. And we were also testing other drugs that were available, not used for cancer, to see if they would work. Sure, we discovered some of those too. But I did something a little bit subversive, and as you know, if you want to be disruptive, you got to sometimes disrupt yourself in order to be able to do this. So this is like our experiment that we were doing at the Angiogenesis Foundation. We decided to disrupt ourselves. So we said, we have a whole system of drugs to test. Let's remove half of them and let's swap them out with powders that came from food. All right, just to see what would happen. And when we actually tested foods in the same system used to develop drugs, food as medicine, tested in the same system that medicines are developed, we found what you see on this bar chart in red. We actually found that dietary factors, stuff that's found in food, could actually cut down the blood supply that would be growing to feed a cancer. In other words, there's anti-angiogenic foods. You could see the green tea, you could see the onions and garlics and red grapes and strawberries. It was really an eye-opener to me. For when I saw these results, it made my jaw drop. And I said, my God, foods have potency just like drugs. I was a skeptic. All right. And it just made me realize, like, this is something that I had to pursue. This was an area of research that I absolutely had to actually look further into. A drug takes a decade and $1 billion or more to be able to develop from scratch to reaching a patient. And then not everyone who needs a treatment can actually get the drug. But a food has immediacy. If you discover something amazing about a food, whether it's matcha, whether it's purple potatoes, whether it's a strawberry, that immediacy could be used beneficially without toxicity. All right, and affordably. And so I just saw this as this experiment is what brought me into the realm of food as medicine.
So I'm going to ask some stupid questions here. So on here, I can see that, for example, soy extract causes less angiogenesis, which
Yes.
from what I understand is the growth of these blood vessels. But does that mean that if I have lots of soy extract or artichoke or parsley or berries, that it's going to cause other parts of my body not to grow blood cells?
So this is the great question. Let me kind of reframe the question as you're asking it. If experiments are able to show that certain foods can prevent blood vessels from growing, will that actually cause a problem with your body's health defenses to keep blood vessels from growing in healthy tissues?
Yeah.
All right. Answer is no. And here's why. As a health defense system, our angiogenesis system is completely designed to yoke in the right number of blood vessels to give just the right amount of blood flow. Not too much, not too little. I call it the Goldilocks zone. You know, Goldilocks, the fairy tale. The bears were home invaders. They broke into the house and they were looking for chairs and porridge and beds. Not too hot, not too cold, but just right. All of our health defenses, including the angiogenesis health defense, is hardwired to keep the body just right. So what that means is that eating foods like artichokes or strawberries or soy can actually help your body prevent extra blood vessels from growing towards cancer, for example, and other disease tissues, but it will not override the body's natural ability to get the right amount of blood vessels to the right tissue. So you don't have to worry about starving your healthy tissues. You're just cutting off the bad blood vessels of the tissue. I call it like a landscaper on a golf course that breaks out the lawnmower to mow that the golf course so it's got a perfect level of the lawn. You're not going to actually carve out a bald spot in a country club. You're going to get just the right amount. Similarly, and we're not talking about this graph. There's another graph that can actually show foods that you can eat that can grow blood vessels, healthy blood vessels, where you want them. And it turns out things like fruit peel can actually do that. And barley can grow new blood vessels. And dark chocolate can actually help to support blood vessels as well. And some of these things can also work on both sides of the equation. They can prune away the bad extra blood vessels, and they can grow them whenever you need them. So your body is sort of like the gardener extraordinaire. It knows exactly how to actually tend. You give them the right ingredients, they know exactly where to put the grass seed, and they know exactly where to mow the lawn.
Have you ever had cancer in your family?
Yes. Cancer has touched my family like it has for most people. I had two uncles years ago that passed away. One passed away from colon cancer, one passed away from liver cancer. And, I was a doctor at the time. And so I felt so helpless because as a doctor, I could diagnose, I could lay hands on, I could feel the hard liver, I could feel the masses, and I felt at the time helpless. Even though I was doing the research, cancer research, and finding future paths, I felt like we're not there yet, and we can't. I couldn't help him. I felt powerless. Fast forward, we're now at a point where we're beginning to see the light at the end of the tunnel. And when my mother had cancer, so my uncle's sister, my mother, wound up having endometrial cancer. She was 80 years old. One day, had some bleeding, went to the hospital, found a mass. She had a hysterectomy to remove her uterus and ovaries, and they found in there an endometrial cancer. That's a cancer of the lining of the uterus. The surgery and a little bit of radiation was supposed to take care of it. Unfortunately, in her case, those little cancer stem cells, and it was microscopic cancers that were present, raced off in her 80-year-old body, which, weaker immune system when you're 80. And within a few months after successfully recovering from the surgery, she had stage 4 cancer everywhere. All right. And her oncologist told me, Dr. Lee, you're a doctor as well. This is serious, and this is pretty much the time of game over. And now times have changed. Science has advanced. Progress has advanced. At that time, when my mother was diagnosed with stage 4 cancer, immunotherapy, the latest and greatest, I think, advancement in cancer treatment, had just broken through and become approved. Immunotherapy is not chemotherapy. It doesn't actually poison the cancer. Immunotherapy is a medicine that you give a cancer patient that wakes up your own immune system. Whether you're a young person or an old person, it can wake up your immune system. All right. And my mother had immunotherapy. She was one of the early patients that got immunotherapy. And her own 80-year-old immune system woke up like an army of super soldiers and went after that cancer. Now, we completely adjusted her diet so that her body between treatments would be as strong as possible, shields raised, as we've been talking about. And we give her a little bit of radiation to help her immune system spot the cancer. Guess what happened? 3 treatments of immunotherapy, three weeks apart. So time 0 is the first treatment. 3 weeks later, the next treatment. 3 weeks after that, the next treatment. All right. So we're talking about a total of 9 weeks of 3 treatments. All right. Of these 3 treatments, we scanned her. Stage 4 went to stage 0.
Wow.
And she never had chemotherapy. Now, chemotherapy can be helpful too with immunotherapy, but this was where I saw firsthand, close up in my own family, the ability to harness your body's own health defenses in a way that I couldn't do for my uncle 15 years ago before, and we lost him. And we were to save my mom. And I can tell you, I literally had dinner with my mom 2 days ago, and she's 90, 91, 10, 11 years later, completely healthy, completely cancer-free. And by the way, this immunotherapy, if we could only get this to work as well for everyone.
Immunotherapy.
This is where we are in the history of medicine. We can see an end. We know how we can get to an end. We've actually seen successes. We just can't get it to work for everyone yet. And there are different ways to actually wake up your immune system. Another way that I'm working on now that a colleague of mine in Germany is working on is also absolutely jaw-droppingly amazing. Imagine this. Somebody has cancer and they're going to get a biopsy no matter what. They're going to take some tissue out to look at it under the microscope. What kind of cancer is it? Is it a brain? Is it a breast? Is it a colon? Is it pancreas? Where is it coming from? You're going to get a diagnosis. Right now, up until recently, that's all we did with the tissue, the biopsy. You just got a result, and it's kind of like a death sentence depending on what type of cancer. And you're supposed to then go to the guidelines and open up the treatment book to say, well, what's the pathway what's the recipe we should follow for treatment? Too often, those recipes don't work very well or for very long. And what if I told you that where we are headed with cancer therapy is a new frontier where you take the tumor with the biopsy, sure, look at it under the microscope, call it out, define what it is, and then you send it to a lab where you do complete full-on genetics. You sequence the entire cancer genome, all right? Right now we do sequence, we take a dozen, 2 dozen, 3 dozen. I'm talking about doing 20, 30,000 genes, right? Right now, most people say it's not worth it. We don't know what we do with all that information. What if I told you if you took a tumor and sequenced all the genes, you find every mutation, every typographical error that we talked about earlier that's in that cancer? Those are the smoking guns of the cancer. Now, what if I took a piece of a little normal blood, normal cells, and sequenced that too? All right. Now, people are hearing me talk who are oncologists or scientists would say, I don't know what you're talking about. That's double the waste of effort because now you're going to sequence the human genome twice in a single patient. What are you going to do with all that information? This is where technology sits in. Artificial intelligence, machine learning. Let's now have a computer compare normal cells with tumor cells, back and forth and back and forth and back and forth, subtract out all the mutations that are found in normal cells, leaving only the smoking gun mutations in the cancer. A couple hundred are going to be left. Those are the smoking guns. Those are the doers that led to this cancer. Now imagine, and I'm going to give you an analogy here. Do you remember that Tom Cruise movie, Minority Report?
Yeah.
So you remember, like he was wearing these gloves and you have a glass pane and you can actually move the things around on the glass with your fingertips, right? So now imagine you can take these human, the cancer mutations on the bottom of this glass screen, and you can just randomly with your fingers pick out 20 random mutations and move them up on the screen. All right, now you've just picked out the mutations, and now you can connect the mutations together. I call it a pearl necklace. Imagine every mutation's a pearl, and you connect them together with the string that connects the pearl necklace. Now you get what I'm saying? Like now we've taken the tumor, find out the doers, the smoking guns. Now we've strung them together. Okay, this is the most wanted sign that you would actually place out for the criminal.
That's a message from the CEO. The team needs a bigger space. And this is Revolut Business, where you earn up to 3.51% annual interest on your savings, paid daily, which you can withdraw anytime. Designed for efficiency, built for business.
And now imagine you hit print technology, and now you have a protein printer that prints out those smoking guns as a protein full of your own individual cancer of that particular person. Now you take that protein and you inject it under the skin, and you're challenging your own immune system. You're vaccinating yourself with your own cancer, and you're causing your own immune system to say, aha, this is a bad guy. We're going to develop antibodies to go find our immune system. We're going to get ratcheted up to go find that cancer. Well, this is happening right now in clinical trials. I have a colleague named Saskia Biskup that is actually developing peptide vaccine treatments against cancer. And if you want to see some amazing results, there was a paper we published in Nature Communications about a year ago that showed in more than 100 people with glioblastoma. That is a game over brain cancer. Nobody lives more than a couple of years with this. All right. That with this treatment, we've been able to actually show that some patients with their own immune system woken up can actually keep them alive and cancer free. Brain cancer, like that is no win situation, impossible to possible. And actually, somebody who I've just recruited as an ambassador to my nonprofit organization, the Angiogenesis Foundation, I strongly encourage people who want to have a modicum of hope, who wants to see what I'm talking about in real life on social media. There's a woman named Rebecca Devine. She's okay with me giving her name. Her handle is That Brainy Blonde. It's a triple entendre. She's blonde, she's very smart, but she had a glioblastoma 7 years ago. And she is thriving, alive with this immunotherapy. So between my mother, Rebecca Devine, I'm just telling you, like I've known well over a dozen people who there's no way they'd be here today if it wasn't for the scientific advances that all shore up the body's health defense systems, specifically the immune system. But the drugs alone aren't enough. You really can take advantage at home of your own diet and lifestyle to be able to tip those odds in your favor.
I've heard you say that immunotherapy is more likely to be successful if you have certain bacteria in your gut.
Yeah,
What is that?
Okay. So in 2017, I helped to convene a cancer research conference in Paris. And we called it Rethinking Cancer. And we brought the world's best minds out there. And one of the researchers named Dr. Laurence Zitvogel, she's in Paris, works in Paris at the Institut Gustave Roussy. She is an immuno-oncologist, so she studies immunotherapy for cancer. And at the time, we asked her to present some groundbreaking results that were embargoed at the time. So our conference was the first time it was ever presented. And she said in 100 people who were receiving immunotherapy for different types of cancer, that if you looked at the difference between people who responded, did well, versus people who didn't respond, didn't do well, died. All right, and that's the frustration with the types of treatments my mom had. Some people do well, some people don't do well. We pull our hair out trying to figure out like what's going on. How do we make people do better? Well, it turns out that when you compare everything, gender, age, comorbidities, all the other genetic factors, the research that was presented showed that there was no differences between the groups of responders, people who did well versus people who didn't do well for immunotherapy, except for one thing. That one thing was one bacteria. The responders had one bacteria called Akkermansia muciniphila. So most bacteria have a genus and species, first name, last name. First name is Akkermansia, last name is muciniphila. Okay, it likes to grow in mucus, muciniphila. Where is there a lot of mucus? In the colon. Where's the colon? That's on this model, the blue area. So Akkermansia grows right here in the cecum, which is the pouch in the colon right at the beginning before you take the up elevator to the top of the colon. That's where it grows. If the people had that Akkermansia, they would respond to immunotherapy. So what the researcher did, she took out the Akkermansia and brought it to her lab of the responders from humans and gave it to mice who were not responding to immunotherapy. Boom. She'd resurrect the immune response to kill the cancer. So this is one of the first bacteria, and there may be many, many that we haven't yet discovered. All right, so like my whole career has all been about discovery. There may be more bacteria, but we discovered at least one, the presence of which seems to be absolutely vital. If you are a patient receiving immunotherapy, the type of immunotherapy called checkpoint inhibitors, if you want to tip the odds in your own favor of being a responder. Now, how do you get Akkermansia? Well, at the time, there was no Akkermansia probiotics. Now you can actually find Akkermansia probiotics. But at the time this was coming out, you had to grow your own Akkermansia, DIY Akkermansia. All right. So how do you grow it? Well, it turns out that there are certain foods you can eat that grow Akkermansia. What are those foods? Pomegranate, pomegranate juice, pomegranate seeds will grow Akkermansia. Cranberries, cranberry juice, dried cranberries will grow Akkermansia. Concord grape juice or Concord grapes will grow Akkermansia. Chili peppers will actually grow Akkermansia. Chinese black vinegar. You ever go to dim sum and have soup dumplings?
Oh yeah.
The black vinegar sauce that they use for as a condiment to the soup dumplings? Chinese black vinegar. That will prompt your body to grow Akkermansia as well.
So what is your diet of preference then? There's so many different diets that people speak about when they talk about cancer and other chronic diseases. As I think I said to you beforehand, I'm on an extremely low carb diet, which is like verges on keto, but I kind of bounce in and out of ketosis. What do you think of? Let's start with the ketogenic diet. Do you have a view on that kind of diet?
Yeah. So let me just give you my perspective on diets. Lots of different diets out there. They're all designed with kind of a specific perspective and a particular goal in mind. Oftentimes, diet, whether you're talking about South Beach or keto or carnivore or vegan, they're all designed to achieve a certain kind of goal. Most of them are very, very difficult to maintain for a long period of time. Now, people are vegans and vegetarians, and that's something that, because of the diversity of the food that you can actually maintain that. But if you're only doing pure keto, that's very difficult to do. So most popular trending diets are short-lived, short-term solutions, and they'll kind of force your body to do something. All right, but you can't keep it up. And so a diet that you can't keep up isn't, to me, a very practical diet, because you're going to bursts of activity that you just can't do your whole life. I find that it's much more healthy in the long run if you can find a sustainable way of eating that works for you personally, that you can maintain, and that you're going to enjoy your life as well. Most people who are on really strict diets, they're not enjoying their diet. Like people who only eat carnivore diet or only eat raw food. Listen, don't con me. You can't be enjoying eating raw food, your entire life, navigating through society and seeing other people, eat a big steaming plate of pasta or something, or going to a Chinese restaurant. So what I'm saying is that trending diets are well-intentioned. They often are designed to do one thing, but you can't keep it up. So it doesn't really, at the end of the day, contribute to the ultimate goal. What I prefer, and where I think the science takes us, where the next frontier for like lifetime health is tearing a page from the playbook of some of the healthiest cuisines in the world. And I would say Mediterranean is the hotbed, the crucible of a lot of healthy diets. Not just the blue zones, I think, but there are blue zones in the Mediterranean. Also Asia. There's a blue zone in Asia as well. But, look, there's also a blue zone in Latin America. If you take a look at the common denominator of what's going on in the Mediterranean and Asia, is a very healthy, plant-forward, fresh, seasonal, healthy cooking oils, healthy preparation style, absolutely delicious way of eating. I mean, come on. If I were to take you to a Mediterranean restaurant or to an Asian restaurant, I would find it hard to believe that you and I opening the menu couldn't find something that we would enjoy eating, right? So Mediterranean is how I tell people I actually eat. That's my, quote, diet.
Why do the Japanese seem to do so well when we think about the world's healthiest countries? Looking at some data here, a variety of different graphs that I have in front of me, and Japan seems to continually come out on top as it relates to health span.
Yeah. Okay. Well, there's no one single factor, I think, that was responsible for it, but it is true. The Japanese demographics show consistently some of the oldest, longest living people. They tend, first and foremost, okay, before we talk about what they eat, let me tell you what they don't do. They don't overeat. And I'm giving you a purposeful pause there, because overeating, caloric loading, okay, is very damaging to our metabolism. It actually counters our ability to live long. It actually speeds up our cellular aging. it sets up inflammation. So by cutting down on your caloric intake every day, that's one of the things is that the Japanese culture, the culinary and gastronomic approach to food in Japan tends to favor modesty, under eating rather than overeating.
I've got a question here.
Yeah.
How do I know if I'm overeating?
Okay, so there's a Confucian saying that's been translated into the Japanese that's a mantra, which is Hara Hachi Bun Mi, which means stop eating when you're 80% full.
I asked this question because I have a friend who was, I think it was on this podcast, so I don't think I'm revealing anything. He actually sat next to me when Peter Attia was talking to him. He's Jack, who runs production for us. He had his DEXA scan done, which looks at your visceral fat, subcutaneous fat, muscle mass, bone density, those kinds of things.
Yeah.
And he's a slim guy. He's much slimmer than I am. And the diagnosis that came back from the doctor basically said, you're overnourished. And when I look at him, he doesn't look like someone that's overnourished. And the doctor essentially said to him that you need to reduce your calories. Now I'm looking at this guy thinking this is a slim guy. This guy's like much, much slimmer than I am. Yet the doctor's telling him that he's overeating.
Yeah, so I wrote a whole book on this called Eat to Beat Your Diet, which is not a diet book. It's an anti-diet book that really uncloaks the new science of your metabolism. And what I try to say in terms of sharing that science is that, first of all, body fat, which societally is regarded as a bad thing. Nobody wants fat, right? Is actually a good thing. Body fat's an organ in the body. Did you know that? Like it's one of our body organs, our body fat. It is distributed throughout our body. And what does it do as an organ? Well, it's got some cushioning effect. So, like if you didn't have any body fat, by the way, you tripped on the stairs and you hit the ground, you might rupture your organs. All right. So it has a little bit of a cushion effect, marshmallowy cushion effect. But our fat also is a fuel tank to store fuel. So when we're eating calories, our calories are our energy. We're eating food, we're eating calories. That's our energy. That's a fuel our body runs off of. I always tell people, if you have a car and you're filling it up with gasoline at the petrol station or the gas station, you don't even think about your gas until your fuel gauge starts to run low. And the same thing for our bodies.
Oh, jeez.
We don't think about our fuel until we're hungry. And our hunger in our brain and our gut is really as our fuel tank that signals, we're getting towards that red line, better go fill up. Now, unlike a gas station or petrol station, there's no clicker on our body. We can keep stuffing food into our system. We can very easily overload our fuel tank. Okay, that is, you've got to cut back on your calories. That's what your friend heard when the doctor was saying you got to cut back on your calories because you're overloading on fuel. So where does the fat build up? There's different areas that fat in your body builds up. Now, the fat there's white fat and there's brown fat. White fat can be under your chin, could be under your arms, could be in your thighs and your butt, could be the muffin top, around your waist. But that's not where the most dangerous fat builds up. The most dangerous fat, inflammatory fat, is a fat that builds up inside the tube of your body. So if you think of your body like a poster tube, okay, inside that tube, all this gut is, the body cavity, if you were to slice this body in half and look at a cross section, all right, it's a tube. You can fill any of these interstitial areas between organs you can pack with fat. So think about, you're going to FedEx something to somebody, overnight mail, a vase or a glass or bottle of wine or whatever, you're going to pack it full of peanuts and you're going to put it into a package. Well, look, you can get a big box and put a lot more peanuts on, or you can take a skinny box that would just fit it and you'll put it in. So it doesn't really matter the size of your tube. You could be a skinny person and you could pack it with a lot of peanuts, in this case, visceral fat. And that's what you're talking about in a skinny person with too much visceral fat, too many peanuts packed in there. And that is a result of overconsumption of calories, that fat, that energy, the fuel tanks building up within a skinny body.
Yeah.
And that's what we call skinny fat.
Still like mildly in shock about it because I saw his results, I panicked. So the next day, I also went to the same clinic as him. I had my DEXA scan done, and it came back and said that I had, quote, 0 visceral fat. So my results from Dr. Peter Attia said I had 0 visceral fat, which he said was rare. But I had subcutaneous fat, which is the fat on the outside, more than Jack did. So Jack had visceral fat, which is the fat inside us, and he has like almost no subcutaneous fat, and I'm kind of the inverse of that. And I don't understand I was trying to figure out, why is my body, when I eat something, putting the fat subcutaneously on the outside, whereas Jack's body is putting the fat on the inside, which is the dangerous fat.
Here is an interesting thing. Let's look at the opposite of building up subcutaneous fat.
Which is the external fat, not the dangerous
The external fat, yeah. So, okay, so there's two kinds of body fat, white fat and brown fat. They're all good. They're all beneficial. White fat can be subcutaneous. Subcutaneous means under the skin, under your jaw, under the skin of your jaw, under your arms, on your thighs. That's subcutaneous. White fat can also be visceral fat. That's deep inside the tube of your body. And then brown fat is not wiggly jiggly like white fat. Brown fat is wafer thin, and it's plastered around our neck. It's behind our breastbone, a little bit between our shoulder blades, a little bit in our belly. And brown fat actually is metabolically active, and it fires up a process called thermogenesis to burn down harmful visceral extra body fat. So you can use good fat to burn down bad fat, which is the amazing thing. Again, fat is not universally bad. It's actually quite good. And so one of the things that I think is really important to know is that when you've got too much visceral fat, you've got too much inflammation, but you can actually use your brown fat to try to control that, to try to burn it down. Brown fat, by the way, is activated by foods and activated by cold temperatures. So when you talk about your cold plunge, brown fat can actually light up. So you just handed me a card. I'll describe this, in which there's two pictures of a figure. And one of the picture on the left is room temperature, and it's not cold, it's regular room temperature, and this is the same individual, by the way, and you can't see anything lighting up because the brown fat is just adjusted to normal room temperature. Now, on the right-hand side is when you actually lower the temperature.
In an ice bath or something?
No, this is actually just lowering the room temperature
Oh,
really,
really?
really cold, like
Okay.
a laboratory condition, lowering the room temperature. And boom, you see all this brown fat lighting up. Remember I told you it's plastered around the neck, behind the breastbone, a little bit in your belly. And this is Mother Nature's adaptation in evolution to help animals survive cold temperatures. So before we had thermostats and room heaters, think about by the way, brown fat was discovered in hibernating animals. There was a zoologist who was plucked out a kind of a muskrat-looking animal from hibernation and dissected it and found that there was this brown lump that was between its shoulder blades, and nobody knew what it was. The more researchers and biologists and zoologists looked at animals that were hibernating, they found this very consistently. In fact, they called that brown mass first a hibernoma. Hibernating? Oma, a mass, we don't know what it does, okay? A hibernoma, that's what it was known until 1930s. In the 1930s at UCLA, a researcher who, in the beginning, we didn't have microscopes, and then we had microscopes, and we had really great microscopes, and all of a sudden in the 1930s, the researcher at UCLA said, that hibernoma is actually made of fat cells, and those fat cells are brown, and the reason they're brown is because they have a lot of mitochondria in it. Mitochondria being the fuel cells of our body, like the batteries of our body. They're the energy generators in our cell. And mitochondria are very rich in iron. And when iron is oxidized, it turns brown, like a pile of nails that you've put outside your door. And the outdoors, silver nails will turn brown. Brown fat packed with mitochondria, energy generating, packed with iron, oxidizes, turns brown. That's why brown fat is brown. And so what happens is that in cold temperatures, like in hibernation in winter, the brown fat fires up, and that's what keeps these hibernating animals warm throughout the winter so they don't freeze to death. Now, humans, we can actually use that to our advantage. We can actually activate our brown fat. Cold bath will do it. Sleeping in cooler rooms will actually start to activate it as well. When that, by the way, when those mitochondria fire up, they're burning energy. You know where they draw that energy from? From your white fat, from your visceral fat first. So you want brown fat, good fat to burn down bad fat, visceral fat, white fat. You want to sleep in a cool room, or you want to go into a cold bath. And there are lots of foods that will also, you can eat foods to activate your brown fat to burn down harmful fat.
And then the last thing is cortisol, the job that we have. I know that it doesn't sound like a hard job to be a podcaster, but in Jack's role, he's basically working 7 days a week. Sometimes, he's working early hours of the morning. He's traveling around the world with me to come to these studios. I observe it. It's a stressful job. So I was wondering if all of these factors play a role in how our body chooses where to store things. And really like the role of cortisol in determining fat storage is so interesting to me. Like the role of stress in determining where our fat is stored.
Yeah, well, I mean, cortisol is a stress hormone. It actually snaps us into action. It actually is also healing. Cortisol is got multiple job descriptions. It's kind of like a Swiss Army knife of hormones. In small bursts, cortisol, incredible. And it makes you feel good as well. I mean, it's a kind of basically it's a type of body steroid. So cortisol is a very, very useful hormone for all kinds of reasons. But long-term stress will lead to excessive, prolonged, unabated cortisol secretion. And when your cortisol levels are up, and relentlessly, that then actually changes your metabolism. It definitely alters the ability for your fat to actually conduct its metabolism. I mean, fat releases itself about 15 different hormones. So when you mess up the hormonal structure, the endocrine structure of your own body fat with something like excessive cortisol, you'll actually begin to derail your own metabolism. So it's not the short-term cortisol, it's a long-term cortisol that's actually the most damaging.
Why is visceral fat dangerous? Because people refer to it as being linked with a lot of chronic disease and cancers and stuff like that. But what evidence do we have that it's dangerous, and why is it dangerous?
Yeah, because the tube of your body with all the organs packed into it, just like we're seeing here. Look at all these organs packed in. You got your liver, you got your stomach, you got your colon and your small intestines. That's packed into the tube. All right. It's kind of like packing for vacation. Some people are really, really skilled at packing. They can actually fold their socks and their underwear and their pants. And it's like, oh my, you're a genius. You're a packing genius, right? Now, visceral fat grows between those folded shirts and pants, and it fills a lot of space in there. When you have too much of it, not only does it fill up the suitcase of your body, the tube of your body, but it starts to push on organs, which is not healthy because it's all packing inside between the spaces, the potential spaces in there. And then when it grows beyond its own blood supply, the visceral fat starts to starve. It becomes hypoxic, meaning it's not getting enough oxygen, bigger than the amount of blood vessels that are growing in there. And now you've got the center of the fat starved of oxygen. The inflammatory cells start moving in, and now you've got this fat that's outgrown its own blood supply that's now becoming very inflammatory. And because it's packed all throughout the tube of your body into the suitcase of your body, it's leaking out that inflammation everywhere. So think about it, like if you have a neatly packed suitcase and you're like, I'm going to put some lotion and cream, canisters of lotion and cream. I'm going to pack it everywhere in between the spaces. Okay, look, Stephen, pack a few, but let's stop right there. And I'm going to pack like 20 or 30 of them. And you keep on stuffing it. Even though the suitcase, it's a hard suitcase and you can put a lot in there. Now you're starting to press on the clothing. You're going to scrunch up your pants. And here in the body, you're scrunching up your organs. Now, Why don't we make one of those tubes of cream? Let's break one of them open. Now it's leaking. All right, and that's what's happening when your fat is so inflamed, it starts to leak inflammation. Now imagine that cream starts to leak out into the interstices of your suitcase. Now you've got a suitcase, looks skinny on the outside, just looks like a suitcase. It could be a carry-on, but now all the organs, all the clothes you packed so neatly are squeezed and scrunched off, and now the lotion is leaking everywhere. That is the analogy of excess body fat in a small container, spreading out, compressing the organs, and leaking out, and that's why it's dangerous.
Oh gosh, and there's a link there to cancer.
Yeah. So studies have actually shown that, and this was a study done by Cornell in New York, looking at Swedish women who were normal body size or skinny. So you've heard of skinny fat. This is what they were studying. And they looked at these women to see, they did DEXA scans, as you described, to see how much body fat they had. And then they followed them over 13 years. And they actually found that women who did not have extra body fat had, normal risk of breast cancer, but women who had skinny fat, remember all the women in the study, it's 3,000 women, actually were normal body size. They weren't supermodels, but they were just normal size women. Some of them were slimmer than others, but none of them were obese. None of them were overweight, just normal size. But they knew at the baseline what the DEXA scan showed. And what they found is that women who had excess body fat over the period of 13 years had a threefold increase in the risk of developing breast cancer. And it's linked to higher inflammatory markers in their bloodstream, which makes total sense. The leaking body cream, the leaking inflammation, in a skinny tube, all right, or normal size tube, normal suitcase. Look, the suitcase can't expand bigger. It's got a finite size, but it's leaking out. And this is because cancer thrives in an inflammatory environment. If you have inflammation with even a microscopic cancer like we talked about, but a small tumor, putting inflammation in the environment of a cancer is like pouring gasoline on the embers of a fire. You ever go camping, you have a campfire, it's almost out at the very end. Now, if you pour some gasoline in it, boom, whoosh, you're going to have to create a bonfire all over again. That's how dangerous inflammation is. So that's why excess visceral fat, inflammatory fat, is so dangerous and linked to cancer. And by the way, not just breast cancer. It turns out that excess visceral fat has been linked to 14 other cancers, increased risk of 14 other cancers, everything from colon, ovarian, lung, breast, prostate. It's a growing list of cancers that seem to be would be at higher risk if you had high levels of visceral fat, and it makes total sense given the inflammation.
Shocking study that I read about this a while ago in JAMA, and it examined the impact of illness anxiety disorder, which they call IAD, formerly known as hypochondriitis, and the impact that being avoidant of health and illness has on your mortality rates. And the research analysed data from approximately 45,000 individuals over a 24-year period, comparing 4,000 patients who had this anxiety around their health and were avoidant. And the findings showed that those with IAD, that were anxious about health and getting checkups and those kinds of things, had an 84% higher risk of death during the study period, dying on average 5 years earlier than those without the disorder. And again, causation's hard to establish there because it could mean that being an anxious person means your cortisol's up anyway. Being an anxious person means you make worse dietary choices. But I've always remembered that and thought about how it's, I find it much better, especially as I age and I'm going to be now confronted with more risks, especially things in men like prostate cancer. Being on the front foot is probably a better approach.
Well, and if you take some proactive approaches using food as medicine, where you got to eat you got to eat every day. Most people eat 3 times a day. Most people encounter food about 5 times a day: breakfast, lunch, dinner, and a couple of snacks. If you realize every time you're encountering food is an opportunity to choose a food, an ingredient that actually supports raises your shields, supports your health defense systems, and know that, and trust your body, trust your health defense systems, that if you raise your shields, you're less likely to actually have problems later. Won't eliminate them. Okay, there's no guarantees in life, but it'll lower the risk. Here's an example, Stephen. Research studies have shown that tomatoes are good for overall health. You mentioned prostate cancer, so studies have shown that men who eat tomatoes regularly, cooked tomatoes, actually have a 29% lower risk of developing prostate cancer. It's pretty good. What's the dose of tomatoes that you need, cooked tomatoes you need to eat? 2 to 3 servings per week. All right. I can probably accomplish that. How much each time? Do I got to eat a wheelbarrow of tomato each time? No. The typical serving that this study supports is just half a cup of cooked tomatoes is per serving.
How do they know this stuff? Because obviously, how do they isolate that in a test?
So these are from large-scale population studies. In this case, it's a epidemiological study called the Health Professionals Follow-Up Study, where they developed hypotheses and they looked at outcomes over the course of 25 years, and they looked for statistical correlations. So they found that tomatoes lower the risk of prostate cancer based on people reporting their tomato eating. Then they actually went back and looked at the report within the data collected. How much should they eat on average every week? So that then you can actually back calculate the dose. All right. Now, I told you earlier about the way that I do research, foods and medicine research. Let's take it further. Let's figure out what's in a tomato. Mm-hmm. Well, tomatoes have lots of. It's got sugar. It's got some salt. It's got carotenoids, which are bioactives. One of which is lycopene. Well, okay, what does lycopene do? Guess what lycopene does? Lycopene in the lab will cut off the blood supply to tumors. Anti-angiogenesis. Shores up your health defense systems, prevents cancer from getting a blood supply. And in fact, in correlative studies, they've actually taken the prostate cancer biopsies of men who did not avoid prostate cancer. So they were tomato eaters who went on to develop prostate cancer anyway. Nothing takes your risk to zero. And they looked at them, and what they found is that those men who ate more tomatoes had fewer blood vessels in their prostate cancer, and the prostate cancer was also less aggressive. So people who ate 4 times and 5 times and 6 times had fewer and less aggressive blood vessels growing into their prostate cancer. So that's an example where, if I told you, consider having some cooked tomatoes a few times a week, and you don't need a lot. Even half a cup is enough. Oh, why cook tomatoes? Well, because it turns out lycopene is a natural chemical that in its native form, pick a tomato off the vine and eat it that like an apple, it's absorbed in your body, but not avidly, not as much as possible. What is that?
That is coffee.
Okay.
And we've been talking a little bit about brown fat.
Yeah.
Mm-hmm.
Is there a link between fat and coffee? Because I had someone the other day saying that if you want to lose weight, drink coffee. And I wasn't sure if that was...
Well, so coffee is a beverage made with coffee beans. Coffee beans are plant-based foods. Coffee beans contain many polyphenols, including chlorogenic acid. Chlorogenic acid is anti-inflammatory. Chlorogenic acid also turns on your brown fat. So it triggers your brown fat, and it causes your brown fat, the mitochondria, to fire up, undergo thermogenesis to burn down harmful white fat or visceral fat. So a cup of coffee a day, or actually the dose is actually about 3 to 4 cups of coffee a day, will definitely cause your brown fat, good fat, to burn down your bad fat, your harmful fat, your visceral fat.
What about fasting? People often talk about fasting as an intervention, as a form of medicine for the body. And I wondered if you had a take on that.
Yeah, listen, fasting is beneficial. Fasting's good, and fasting's very old. It's not just a recent trend. If you go back thousands of years, I mean, if you look at some of the oldest religions in the world, fasting was part of their ritual that would happen, throughout the year. Now, people go, well, what about intermittent fasting? How long should I fast? I try to tell people there is no magic formula for success for fasting, because we're all different. And our bodies are different, our lifestyles are different. There's no universal fasting protocol that's going to be one size fits all. However, I will tell you an easy way to fast, because fasting is very natural to us, is just paying attention to what you do every day and be mindful. So when you're sleeping, you're not eating. When you're not eating, you're fasting. So I try to be reassuring. So guess what? You're fasting every day anyway. When you fall asleep, you're fasting. All right. And the longer you're not eating and sleeping, the more time your metabolism, the Ferrari of your metabolism of your body, can switch gears to burn down any extra fat that's accumulated. Now, if you've been eating whatever you want over time, you probably built up a lot of extra fat. Now, from your scans, apparently not. You don't have too much. All right. But if you're fasting regularly, you're burning down all that extra stuff. Okay. And so then how do you optimize that without having to calendarize your fast and figure out, how to schedule your meals? I try to make things as scientific, but as practical as possible. And so I tell people, you want to really get involved in intermittent fasting. Easiest way is take advantage of what you're doing already. And that is, if you're sleeping, try to sleep 8 hours a day. So how do you sleep 8 hours a day? I don't know. I said, if you go to bed at 11 o'clock, get up at 7 o'clock, you get to 8 hours of sleep. All right. We know that that's the sweet spot for your brain, for your metabolism, for burning on harmful body fat. How do you get more out of that? How do you turn that 8 hours of fasting into more? Well, what I say is that the night before, when you're eating dinner, let's say you eat from 7 to 8 o'clock in the evening. What I say is that when you finish dinner and you put your dishes away in the sink or in the dishwasher, that's it. No more eating. Stop eating. Nothing until the next day. If you're going to have dessert or whatever, squeeze it in there, but don't take a snack with you and sit by the television or, absentmindedly gobble food, and don't, before you go to bed, eat a big chunk of whatever. Okay. Now you got 3 hours before you go to bed at 11. Again, this is all a theoretical model. 3 hours of not eating. Your blood sugar goes down. Your insulin goes down because you're not eating anymore. All right. Now your metabolism shifts gears 3 hours earlier. Okay. Now you've got those 8 hours plus 3 hours. You got 11 hours. Now, when you get up in the morning, okay, let's say you get up at 7 in the morning, don't do what our moms told us to do, right? So if you were like me growing up, my mom, when I got up, was like, hurry up and get to breakfast and eat something so you have enough energy to actually go to school and learn something. All right. So I developed this instinct of actually just getting up and eating as quickly as I can, getting some breakfast in. What if I told you that what I do now, when I get up in the morning, I deliberately don't do what my mother told me to do. I get up, I take my time getting ready, I get dressed. I don't eat anything right away. In fact, if I'm dressed and I'm ready for the day, I might go check it out. I might go outside and take a look at the outside. I might go for a quick walk or check my emails, or I might read a chapter of a book or read a few pages of a book. I wait at least an hour before I eat anything. Now let's do the math, Stephen. 8 o'clock, stop eating. 11 o'clock, go to bed, 3 hours. 11 to 7, 8 hours. 3 plus 8 is equal to 11 hours. I got 11 hours of fasting in. Now I get up and I don't eat for another hour. Boom, 12 hours of fasting, just like that. Okay. Now, if you really want to do that 16-hour fasting, 16-8, just skip breakfast and get to lunch. And as long as you don't overeat at lunch, which does require a little discipline after you go for your fasting window, that you don't overeat and you're eating the right foods, that's how you actually get to do intermittent fasting in the most natural way possible.
So there's one part of the body that we haven't talked about, which is, and my little mannequin here, inside its head, the brain.
Yeah.
And I'm wondering how some of the themes we've talked about link to one of the most common brain diseases which people talk about, which is Alzheimer's and dementia. We talked about, I can't say that long word, but angiogenesis. Is there a link between angiogenesis, what we in the brain, health, dementia, Alzheimer's?
Yeah, absolutely. So I mentioned to you that the human body's got 60,000 miles worth of blood vessels that are coursing through the entire body, bringing the oxygen and nutrients through the highways and byways of health. All right. 400 miles of those blood vessels are in your brain. 400 miles of blood vessels are actually coursing through our brain. And our brain is super metabolically active, where the engine of the brain is functioning all the time, regardless of your IQ, regardless of what type of task you do. Our brain is very, very metabolically active, highly dependent upon a healthy circulation. Now, what we do know, as people get older is that problems can occur with brain function. And the reason I'm framing it this way is that it's quick to jump to a term that people use like dementia or Alzheimer's disease, thinking it's one thing. But in fact, dementia is just a descriptive term for your cognition not working properly, most commonly as you actually age. Alzheimer's, even though it is one type of diagnosis, is probably several different kinds of disease as well. And we do know that there are different types of dementia. Alzheimer's is a subset of dementia. Alzheimer's dementia. There's a more common type of dementia called vascular dementia. And that's where those 400 miles of blood vessels in your body actually narrow, get hard, get clogged up, and don't have good blood flow. So you can imagine if you were to actually interrupt the sprinkler system, the tubing, the blood vessels, the tributaries bringing oxygen to your brain within those blood vessels, okay, over time, your brain is not going to function very well. So vascular dementia is by far the more common type of dementia. So what can we do to maintain healthy angiogenic blood vessels throughout the course of our lives? For anybody who aspires towards longevity, all right, you should be thinking about how to avert that path where your blood vessels, your circulation to your brain gets impaired. The more vascular, blood vessel healthy, angiogenesis supporting diet and lifestyle and medications that you take, the better it's actually going to be. Now, here's what's interesting. What are some of those things? Turns out that dark chocolate, plant-based foods, the cacao, actually helps your body produce something called nitric oxide. Nitric oxide actually widens your blood vessels so you get better blood flow. So dark chocolate is one of those foods that actually seems to be able to promote better vascular health, including in the brain. Now, there are other foods that can produce nitric oxide as well. Beetroot actually can produce nitric oxide. Spinach can produce nitric oxide as well. Those are vascular healthy. Now, here's the other thing. When you produce nitric oxide, like with these foods, you know what nitric oxide does? It recruits stem cells, healthy stem cells, not cancer stem cells, but healthy stem cells from your bone marrow.
Stem cells are?
Stem cells are primitive cells that can turn into anything you need them to be. Turn into a brain, heart, lung, liver, skin, hair. Our stem cells actually regenerate us from the inside out. Now, you know that one of the things that happens as we get older is our brain atrophies and can start to degenerate. It shrinks. Literally a scan of an older person, the brain matter, the mass of the brain shrinks inside the skull. It's like a cotton shirt that shrank. And you see this actually in a scan. And so in order to be able to try to keep the shrinking from happening, you want to make sure there's good blood flow going, which actually helps to keep the brain growing in a healthy and maintained in a healthy sort of way. So stem cells that are recruited by nitric oxide actually can help to also regenerate the blood vessels and keep the blood vessels healthy, feeding the brain. That's the connection between Alzheimer's and dementia and angiogenesis. Now, for Alzheimer's, I worked with a colleague, Dr. Anthony Vagnucci, some years ago, and we published what was then an editorial in The Lancet, a very prestigious British medical publication. And we were connecting the dots between angiogenesis and Alzheimer's disease. And here's how it works. Most people assume that if you've got Alzheimer's disease or someone has Alzheimer's disease, they don't have very good blood flow. They're not going to have a lot of angiogenesis. They got problems, right, of their circulation, of course. And in fact, if you look at the blood flow studies, scans, brain scans looking for blood flow in Alzheimer's brains, indeed, you see poorer blood flow in people who have actually Alzheimer's disease. But now, the brains of people with Alzheimer's disease have more blood vessels that aren't working well. So they're abnormal angiogenic blood vessels are not working well. So you don't get good blood flow. So the scans don't show them. They're just not creating blood flow. Guess what those blood vessels are doing, those abnormal blood vessels? They have been discovered to secrete a neurotoxin that kills your brain cells. So abnormal angiogenesis in Alzheimer's disease grows blood vessels that don't create blood flow, but they secrete a toxin that kills brain cells. And they also secrete the precursor to build up the plaque So we published this as a hypothesis in an editorial in the Lancet, and now there's a whole field looking at angiogenesis and Alzheimer's disease.
It's crazy how this all stems back to this idea that food is medicine.
Yeah, I mean, listen, before we had medicine as medicine, before we had pharmaceuticals in the 1930s, that's all we had. That's all humans had, our diet and lifestyle for medicines, and so I think that that's really, I think what's happened is that during the Industrial Revolution that occurred with pharmaceuticals, we put aside a tool in the toolbox that we've always had. In fact, that's the only thing we had before.
Yes,
and we
correct.
focused myopically just on what pharmaceuticals can do. Now, I'm telling you, as somebody who's developed biopharmaceuticals and who is still very much involved in that, new medicines can be life-saving. Old medicines can be life-saving. And so you never want to throw out the baby with the bathwater. What we have forgotten about is that tool in the toolbox that's been with humanity forever, which is what we do with our food. And what I'm saying is that what we can do now with the work that I'm doing in food as medicine is we can take the modern science, that deep probe, that extraordinary level of sophistication that we use for drug development, and we can use it, apply it to understand why our foods help us, which foods help us, and what types of outcomes we're actually looking for. And so food as medicine, bringing it back into the fold, is just replacing a tool in the toolbox. But now we are actually fortifying it with the knowledge provided by science of what we should choose and when and why.
Supplementation. Are you a fan of supplementation? Because I take a couple of supplements every morning, things like creatine and omega-3 and vitamin D. Do you take supplements?
Yep. Yes, I do. And I'll first say my first off approach is that we should get most of the micronutrients that we need to be healthy from our food. Use your food to our advantage, because single foods will have hundreds of different polyphenols and fiber and all kinds of other beneficial things. So, and vitamins and minerals. So our food is a much more efficient way to get all of our micronutrients. However, supplements can be helpful in the literal translation of the word supplement, which means topping off. So if you can't get everything that you need from your food, then feel free to top it off. And that's what I actually do as well. But vitamin D, I do it as well. Omega-3 fatty acids, another good top off to actually use for a supplement. And by the way, there are some probiotics that I feel that it's prudent to actually have in my body. So I'm not giving a general recommendation. I'm just telling you what I do, right? That's what we're talking about. Everything, it's personal. It's personal to them. But we talked earlier about the Akkermansia, right? So I do eat the foods that support Akkermansia, the pomegranate, et cetera, and the chili peppers. But I'm going to take the supplement because I've seen the data that shows how important it can be. Oh, and Akkermansia improves your metabolism, lowers the risk of metabolic syndrome. There might even be some clues that Akkermansia might also lower the risk of dementia development later on as well. So, hey, this is a pretty safe natural bacteria. I'll take that probiotic. And another probiotic I take is called Lactobacillus reuteri, L. reuteri. What does this do? Lowers inflammation, builds immunity. It actually this is the bacteria that text messages the brain. We talked about the brain. And it causes our brain to release social hormones like oxytocin. That's a social hormone that makes us feel good. So, why wouldn't I actually take that? And, one last thing, Lactobacillus reuteri the kind I take is chewable. Why wouldn't you just take a capsule? Well, it turns out that this same bacteria, Lactobacillus reuteri, it's good for the gut, but if you chew it up, this is the bacteria that kills the bacteria that causes cavities and gum disease. I haven't had a cavity in well over a decade, And so again, this is one of these types of practical things that just knowing the science and knowing what I do and where I don't need enough. It's hard to get enough vitamin D, hard enough to get omega-3s. I will actually top off on those.
I'm wondering, I've got these two great books in front of me, Eat to Beat Disease, which is a New York Times bestseller, and Eat to Beat Your Diet, which is really about burning fat, healing your metabolism and living longer. I know that you must have some favorite, people use the term superfoods all the time, but there must be some foods where you look at them and just think they are little miracles in their own right. So I wanted to a little challenge for you is if you had to pick 5 of your favorite foods based on the research that you've done, the science you've seen, what would those top 5s be?
I would bring coffee
Okay.
because of all the polyphenols in coffee. I'd bring tea.
Okay.
I tend to drink coffee in the morning and I have tea at night. And I'm not caffeine sensitive, so I can have the tea at night. If you allow me, I'll actually lump those into my beverages
Okay.
under one category. I'll bring tree nuts.
Tree nuts.
Tree nuts, walnuts, almonds, macadamias, pistachios. I love nuts, tree nuts, and not the prepackaged kind, but I like to, kind of like toast them up myself and flavor them myself. I would bring that because of the dietary fiber, the healthy it's a good source of protein, some healthy fats in it as well, and can kill some cancer stem cells while we're at it. Okay, so tree nuts are actually good. I would bring tomatoes because I love tomatoes.
Okay.
It's a great source for hydration, good source of lycopene, which we talked about, good for metabolism. I would take berries. Berries, blueberries, strawberries, raspberries are among my favorites. Raspberries, you might be surprised at this, but raspberries are pound for pound or weight for weight, one of the most fiber-rich foods out there. They're light, they're hollow, packed with fiber, and they've got polyphenols that are useful for lowering inflammation as well. Berries are actually really good. And then, because I follow what I call the Mediterranean style of eating, I love to have those vegetables that are actually used in both the Mediterranean and Asia, Mediterranean style cooking, the bok choy, the kale, chicory, escarole, all of those types of leafy greens. So those would be the 5 I would actually take with me.
And what is the most important thing we didn't talk about that we should have talked about?
I think that one of the most important things that I want people to walk away with is that there's more than 200 foods that I've studied and I've written about in my books, Eat to Beat Disease and Eat to Beat Your Diet, that, I've done all the heavy lifting to help you figure out what foods are healthy that you could consider adding to your diet. But if you notice, I didn't actually give you a formula or a set menu on what to do for health. Because the most important thing I want people to walk away with is that my humanistic approach to this is you should love your food to love your health. And if you could actually do both at the same time, you have to find out what are the foods that resonate with you. What do you prefer? What do you enjoy? So if you could look at 200 healthy foods, which is what I have in my books, and just take a highlighter or a pencil and circle them. Circle the ones you already love. Start and stick with those. You're already way ahead of the game. And that builds confidence that you're actually doing the right things.
And that's what I love about this book in particular, Eat to Beat Disease, is that it also comes with lots of great recipes inside the book. And I think that's super helpful because there's a lot of information here, but this makes it actionable. It's a really iconic book. It's sold so incredibly well because also it's so unbelievably accessible to people who aren't scientists and that are trying to find some things that they can add to their plate. And I think that's essential to the approach that you take as well. You're not someone that's telling us we can't eat nice things and enjoy our life. You're talking about the things that we should be adding to our plate to make our lives more healthy and increase our longevity, which I'm very excited about actually, because you're writing a book about longevity, I hear, and I'm very much awaiting that book. When do you think that'll be due and ready? I don't know.
I'm working on a manuscript, so I'm not ready to give a release date yet, but you'll be the first to know.
Okay, good. We have a closing tradition on this podcast where the last guest leaves a question for the next, not knowing who they're leaving it for. And the question that's been left for you is, how would you be able to tell that your time here on Earth has been successful, that you've achieved what you set out to achieve?
Wow. I think I would have two answers for that represent different sides of the coin. For me, I think if I'm able to have made my immediate community, my family, better, that would be a meaningful life having been lived. And if you look at the whole rest of my career and existence and how I spend my time, I want the work that I've done to resonate with others in a way that can improve their lives. I'm, what I do, I kind of say I'm taking one for the team being the rest of the world. And if I can contribute even a small piece that makes other people's lives better, then I feel like, I've done my job.
Well, that's what you're most certainly doing, my friend, because when I was looking through what you've accomplished in your life, whether it's all of the FDA-approved treatments for over 70 diseases, including cancers, diabetes, chronic wounds, and blindness that you've helped to develop, more than I could possibly count, or whether it's the work that you're doing through your foundation, which I think people should check out, which is a non-profit organization which helps develop treatments for chronic diseases that are based on angiogenesis. You've most certainly done that, and you continue to do that. But even maybe more importantly of all, because there's so many billions of people out there that are starved of the information that you have and that you find in your research laboratory, is you've come out into the world, into the public forum, and you're helping to articulate and demystify these incredibly confusing things that people like me who didn't go and get a PhD or didn't go to Harvard don't understand. And you're masterful at it. You really are masterful. Your ability to break down, I sit here week in, week out speaking to very, very smart people, and not all of them have the very important skill of being able to turn something very complicated into something understandable. And that is a skill you have. It's a real, real gift. And especially your use of like metaphors and analogies, which really cement these ideas in our brain in a way that we can all understand. That for me is a really, really important gift. So long may you continue your work of public communication as well, because for people like me, it can cause a penny drop moment that then leads us to change our lives for the better. So thank you.
Thank you for inviting me. But, I would say that, we also live in a time, again, this is about going into the future. I'm always about moving into the future. Well, we have the platforms. We have, I developed a YouTube channel because I realized it was a place for me to drink from the fire hydrant, distill it, and figure out how I can deliver it in swift fashion, which would have been impossible 10 years ago. So, for example, we talked about how, when my uncles had cancer and passed away, and I felt helpless, then my mother had it some years later, and we had progress. We had the ability to be able to do something different. Similarly, for me, I look at my books, I look at my social channels, my YouTube platform as ways of being able to actually solve a problem that I felt like needed to be solved, but I wasn't really sure how to do it until now.